introduction is, what is your name and what is your current role with synthetic biology?
My name is Leonard Katz, and I am the research director of Synbio and also serve as the industry liaison officer of Synbio.
So what was your trajectory to synthetic biology? How did you become interested in it?
My introduction to synthetic biology really came from a discussion I had with Jay Kiesling about a little more than a year ago. Sort of trying to understand what my next career move would be. I had worked in industry for 30 years, and then I was done with that, and I was doing some consulting, and I was looking to see whether there would be some new opportunity that would interest me, and I talked to Jay. I had seen something about it on the Berkeley website. I had read it, and then I talked with Jay about this, and he asked me to come on board to serve as research director, and then this move to an industry liaison officer also happened. I think what he looked for was somebody who had experience in dealing with industry, and having been there for 35 years, I think he figured that I would have enough experience and understanding to carry out that function.
What were you doing before the industry?
Well, I started my career after a postdoc. I started as actually I was on a faculty at New York University for a brief period of time. And then I decided to go into industry, and then I worked for 3 companies in my career at the research level, starting off as a bench scientist and then moving out of the bench to an office and managing, but always in areas that dealt with pharmaceuticals and antibiotics, particularly natural products, polyketides, that kind of thing. But the research really was, if you wanted to put a label on it, the research was molecular biology and microbiology. And using current definitions, I suppose one could call it synthetic biology as well. And so it turns out that I guess I was practicing synthetic biology without knowing it. And the way we apply it today, it has a very broad definition.
So how would you define synthetic biology?
So synthetic biology is really a term that doesn't have a precise definition, but I think that it's generally agreed that it means the construction using DNA of either something new or the reconstruction of something that exists to make it practical, using synthetic DNA or cloned DNA. But anytime you take DNA from an organism and then put it back, one can agree that we're all doing synthetic biology. That's the basic minimum for synthetic biology. So it depends on how refined you want to make it. So for example, Craig Venter, they synthesize everything, and then they clone that in some way into bacteria, or they could do it in yeasts if they were interested. Synthetic biology doesn't have to use synthesized DNA. You can use DNA that you cloned, extracted from one organism and put it back into another. But the practice is to take that DNA and put it in an organism where you can control its expression, where you can modify it, and ask it to do, and ask pieces to assemble to do something that you would like to see happen. That, in essence, is what we define as synthetic biology. What we also try to do here in Synberg is to apply engineering standards to it so that it's in an organized fashion. There's a measurement around it that we can agree on, and there's a composability issue. In other words, one can take this DNA, use it, standardize it in some way, and then use it in many different applications, much like using a pipe to deliver some fluid through it. The pipe has a standard length and it has standard threads at the end of it. And it really doesn't matter where you get the pipe. You can order a pipe that has a certain dimension and it's always going to have the same threads. And that pipe will connect to another pipe or to a connector of some sort. So it doesn't matter who you buy the pipe from. You're going to get the same pipe. And the idea of synthetic biology is to take a unit, an element, a gene, for example, and use it in a particular application. And it shouldn't matter where you get that DNA from. If it's going to be connected to other DNA, there's standard connections that one would like to see. And this is this composability, or what is referred to as off-the-shelf parts. And so that's one of the goals, is to compose DNA into this off-the-shelf type of components that one can use. Where do we put this DNA? There's a registry that's been developed at MIT, and there are other places for storing these, this DNA. So there's a physical aspect of this DNA, which is cloned in a plasmid or in some form that it's stable so that you can get it back and then amplify it and use it. But more important is the sequence itself, because if you're not interested in using a piece of DNA from somebody's library, you can just have it synthesized, but you know the sequence, so that one can just order up that sequence from a company and they'll make it for you. And so the registry has both the physical aspect as well as the sequence.
Do you want to explain a little about what is Synberg, sorry?
You want me to explain what Synberg is? So Synberg is it's a center, it's a synthetic biology center, and it stands for Synthetic Biology Engineering Research Center, and it's headquartered at UC Berkeley. But it's a center in the abstract form. There's no physical center where everybody in Synberg works. So it's more of an abstract center, and it's composed of 15 professors from 6 different universities. We call these PIs, or principal investigators, as well as a very small staff of full-time people. Myself, Kevin Costa, who's the administrative director, Fernando Del Rosario, who's an analyst who works with us, and Kate Spohr, who's the education outreach manager. We are the permanent employees. Everybody else is a professor at some university who's a member of Synberg. And the projects that are taking place in these PI's labs are really the content of what's going on in Synberg. So these projects relate to each other in terms of whether they fit into a particular thrust